Hi, welcome to the Algebra 2 LINSYS 1 review. Let's get started on number 1. It says graph the data and a trend line. Remember to label the axis. Alright, so we got our points here. We have time, which represents our x-axis, and then plant height, which is going to represent the y. Alright, so let's plot those points on the graph real quick. Let's see if I can find a pin. Alright, so we got 1, 1. We got 2, 1.5. We got 3, 2.5. 4, 3.5. 5, 4. And then we have 6, 5.5, and then 7, 7.5. Alright, and then I'm going to draw a trend line. Alright, so then for number 2 it says use the graphing calculator to find the equation for the line of regression. Alright, so let's do that. So I'm going to start my calculator over. Alright, so step 1 is to go to stat, then go to edit. We're going to put the x values for L1, so 1, 2, 3, 4, 5, 6, 7. And then we got 1, 1.5, 2.5, 3.5, 4, 5.5, 7.5 for L2. So that's going to be the plant height. Alright, so once you have your L1 and L2, always just kind of double check to make sure your numbers are correct in there. Then go to stat, calc, option 4, which is LINREG. We get an A and a B, which is the slope and the y-intercept. If you want to get the R value, you have to make sure your diagnostic is on. So to do that, go to mode, scroll down to stat diagnostic. Here it's off, change it to on, and now we're good. So I'm going to go back to stat, calc, option 4. Alright, so then for the y value, for the slope, we have y equals slope 1.04x. And then for the y-intercept, we have minus 0.5. Alright, then for number 3, we are going to predict the height of the plant after 10 days. So we're going to use this equation, the regression equation, put it into y equals. So 1.04x minus 0.5. Go to table. We know that x represents the number of days, and let's go to day 10. So when x is 10, the plant height is going to be 9.9 inches. Alright, so now let's go to number 4. Alright, so number 4 says solve each system by graphing. For each, state the solution and how many solutions the system has. One solution, no solution, or infinitely many. Alright, so we have two equations here. They're both in standard form. We want to put them in slope-intercept form. So let's do that first. I'm going to start off with x plus y equals 6. There's only one step. The one step is just subtract the x. We get y equals negative x plus 6. For the second equation, we have x minus y equals 2. This one's a two-step, so minus x. We get negative y equals negative x plus 2. And then for the last step, divide by negative 1. We get y equals positive x minus 2. Alright, so now we have two systems, or two equations that are ready to be graphed. I'm going to start off with negative x plus 6. I'm going to start off with the y-intercept, which is plus 6. So the b is 6 on this one. The slope is negative 1. You can think of it as negative 1 over 1. Alright, so we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Alright, then for the second equation, I'm going to start at -2, and then it has a slope of 1, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And then we have one solution, and that one solution is right where the two lines intersect. That solution is 4, 2. 4, 2. Alright, so let's go to number 5. On this one, the bottom equation is in slope-intercept form, so that one's good, but this top one, we just got to do one step to it. It is subtract the x. So we get y equals -x plus 4. Alright, so start off with your y-intercept of plus 4. Again, we have a slope of -1. We know when you have a slope of -1, think of it as -1 over 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Alright, so then let's do this one, the -x plus 2. Start off at 2. We're going to go down 1, right 1, down 1, right 1. And then you could also, or we should also notice that both of these equations have the same slope of -1. And we've talked about if they both have the same slope, they should make the same, or there should be two parallel lines. So let me see if I got this one right. Alright, so here we see two parallel lines. They both have the same slope. And they have 0 solutions. So this is going to be no solution. Alright, so next one, number 6. Let's convert them both to slope-intercept form. I'm going to start off with 2x plus 4y equals 8. This one's a two-step equation. We just have to subtract the 2x and then divide by 4. So first subtract the 2x, then divide the 4. We get y equals -1/2 x plus 2. So this one's ready to be graphed. I'm going to do the other one on the bottom. That one's also a two-step equation. So subtract the x, then divide the 2. We get -1/2 x plus 2. And we notice that both of these equations are the same, exactly the same. Alright, so I'm going to just graph one line to represent both of them. So 2, we're going to go down 1, right 2, because the slope is -1/2. And again, this line is the same as the other line. Alright, so this line and this line are the exact same. So number of solutions, we're going to have an infinite amount of solutions, so I'll just put all real numbers. And our solution is going to be infinitely many. So let's go to page 2. Alright, so for number 7, it says which of the following equations best represents the trend line for the data. Alright, so for both 7 and 8, all we have to do is go to L1 and L2. Alright, so let's plug these into Y1 or L1 and L2. So we're going to go to Stat, Edit. I'm clearing my L1 and L2. For L1, we got 0.5, 1.5, 2, 2.5, 2.75, 3, 3.5, and 4. For L2, 3.8, 7, 8.5, 10, 10.5, 11.5, 12.2, 14.6, Stat Calc. Alright, so again, we did Stat Edit first, then go to Stat Calc. We're going to go to option 4 and just press Enter, Enter, and then we get an A and a B. Right now my diagnostic is on, so I get an R value also. If you want to make sure if your diagnostic is on, you go to Stat Diagnostic, and make sure it's on. Alright, so let's see. We have y equals 2.96x plus 2.45. Alright, so if we round up to the tenths place, we would round up to 3x plus 2.5. Alright, so now next one, number 8, let's do this one on Desmos. Alright, so if you want to use Desmos, we're going to go to the plus sign, go to table, and then for L1, type in your x's. So we have 0.5, 1, 2.5, 2, 3, 3.2, 4, 4.5. And then for the y values, we got 6.2, 6, 5, Alright, so once you have your data in, go to the next line. And we are going to type in Y1, because that represents the Y column. And then we're going to tap the tilde. So that little squiggly line. And then MX1, and then plus B. Alright, so we get Y equals. Alright, so Y equals, the M is negative 0.50, and then the B value is 6.43. Alright, so I wrote it down. Y equals negative 0.50x plus 6.43, and the line that best represents this is going to be y equals negative half x plus 6.5, so B. Alright, so now for number 9, we are going to graph inequalities. Remember, when you graph inequalities, we need to shade. Right now the bottom equation is good, the top one is not. All we have to do is one step. and that one step is just subtracting x. Alright, so let's graph this one. So it's going to be a dotted line because there's no line on the bottom. So 1, 2, 3, 4 for the y-intercept. And then we're going to go down 1, right 1, down 1, right 1. And we are going to get a dotted line. Oops, it should be dotted, not solid. Let me kind of fix that. Alright, so again, this one's a dotted line. So they're both actually going to be dotted. So then we have 2x minus 3. That one's going to, or before we graph that one, let's shade this one. Sorry, so let's shade this one blue. Since the sign is greater than, I'm going to shade everything above it. Alright, so then for the next one, 2x minus 3, I'm going to start off at negative 3. And then since the slope is 2, I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And also make a dotted line. And then we have a symbol of less than, so we are going to shade below. Alright, so this region right here is going to be considered the solution set. The solution set is where both shaded areas intersect. Alright, so now let's check which points are included in the solution set. So 0, 0, that one is outside, so no. 1, 2, that one's another one that's on the outside, so no. 6, 0, 1, 2, 3, 4, 5, 6. That one is inside the solution set. Now let's check 0, 4. That one is not in the solution set. So that one's a no. Alright, so 6, 0 works. Alright, then for number 10, it says Shelly is buying 2 kinds of notebooks for school. A spiral notebook costs $2 and a 3-ring notebook costs $5. She must have at least 6 notebooks. So at least 6 notebooks. The cost of 2 notebooks cannot be more than $20. Alright, so let me just highlight those. At least 6 notebooks. The cost of 2 notebooks cannot be more than $20. So it says write a system of equations to model this situation. Alright, so we have 2 kinds of notebooks. Let's make X the spiral. Notebooks. Let's rewrite this. So number of spiral, I'll put NB for notebooks, and then let's make Y the number of 3-ring notebooks. Alright, so if we're going to make inequalities, we want anything related to cost or money to be together, and anything about quantity to be together. Alright, so we know that 1 spiral notebook costs $2, so that's 2x, so $2 per spiral notebook, and then 3-ring notebooks cost $5, so 5y, $5 per 3 rings, and for the cost, so for the cost of both notebooks, they cannot be more than $20. So cannot be more than is saying it has to be less than or equal to. Right, so we do not want to go over $20, so the total cost has to be less than or equal to $20. Right, so now she must have at least 6 notebooks. So this one's talking about both notebooks together. So her number of spiral notebooks plus her number of 3-ring notebooks have to be at least 6 notebooks, so greater than or equal to 6. So at least is saying that you want a minimum of 6 notebooks, but you could have more than that. So for example, if you go to a fair ride, they might say you have to be at least 5 foot or at least 5 feet to get on the ride, but you could be more than 5 feet. So it's 5 feet or greater, so greater than or equal to. Alright, so we got a system. Alright, so now let's go to number 11. So number 11 says, Rhonda is building a rectangular dog run to keep her dog from running away. The perimeter of the run can be no more than 80 feet, no less than 50 feet, but she wants the length L to be at least 1.5 times as long as the width. Which system of inequalities can be used to find possible values for the length and width of the dog run? Alright, so the perimeter of the run can be no more than 80 feet, no less than 50 feet, but she wants the length to be at least 1/2 as long as the width. Alright, so if it's going to be a rectangle, and we know perimeter is all the sides added up together, but you could also think of it this way. You have 2 lengths, 2 widths, 2 times the length plus 2 times the width is going to equal the perimeter. Alright, so in this situation we have the perimeter. The perimeter of the run can be no more than 80 feet. Alright, so it cannot be more than 80 feet, so it either has to be less than or equal to 80. No less than 50 feet, so she does not want the dog run to be less than 50 feet, so the perimeter has to be greater than or equal to 50. And she wants the length to be at least 1.5 times as long as the width. Or here, before we write this one down, let's see what we could eliminate. We look at option A. This one has the wrong inequality. It's saying that the perimeter has to be greater than 80. That's wrong. B does not have the 2 lengths plus the 2 widths added together, so 2L plus 2W, so that's wrong. And then C kind of looks like what we have. And then B, the perimeter cannot be 1.5. She said she wants it no less than 50 feet. This is saying that the perimeter is going to have to be greater than or equal to 1.5 feet, which doesn't make sense. Alright, so then if we look back at the length has to be at least, so again, at least is greater than or equal to, so at least is just saying you want a minimum of you want a length to be at least 1.5 times as long as the width, so 1.5 W. Let's go see. Alright, so then last page, we are going to graph some inequalities. We have 3 equations. Alright, so let's start off with x is greater than or equal to -2. So we have acronyms, VUX, vertical, x equals, so this is going to be a vertical line at -2, and it's going to be dotted or dashed. And then we got to ask ourselves, where are the x values greater than -2? So that's going to happen on the right side. Alright, so then next equation, y is greater than negative 2x plus 4. So we're going to start at positive 4 and then go down 2, right 1, down 2, right 1. And this one is also going to be a dashed line. Alright, so we got 2 dashed lines, and for this one we're going to shade everything below it. And then for the next one, we got to put it in slope-intercept form. Alright, so again, we got to put this one in slope-intercept form. So we are going to subtract the x. And then since we are dividing by a negative value, it's going to flip the inequality. So this becomes y is greater than or equal to positive x minus 3. Alright, so we flipped due to the negative. Alright, so now let's graph this. We are going to start at negative 3 and then go up 1, right 1. And this one is going to be a solid line. Since the inequality is greater than or equal to everything above it, so then this region is going to contain the slope or the solution set. So then briefly, or describe points that are a solution and when they should not be a solution. So when they are a solution, they are inside the solution set. They are a solid when they are not a solution, outside solution set, on dotted or dashed. Now when you have two lines intersecting, if one is dotted and one is solid, it will be a no solution. Alright, so if on solid and dotted line, be a no solution. Now it is a solution if they're on two. Alright, and then for the last one, this is going to be another I created a sports website about his school's teams. He has a hit counter on his site that lets him know how many people have visited the site. It shows the number of hits on received in the first 2 weeks. Input the data into L2 calculator. Use the graphing calculator to find the regression equation to find the regression equation to fit this data. Find the regression equation, the R value as a mean, and predict the number of hits on day 21 and when it's. Alright, so let's do that. So sit day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hits. We have 5, 10, 1, 24, 28, 30, 33, 27, 27, 46, 50, 31. At calc. With the regression, it y equals 2.41 x plus 11.2, and then we have an r value of 0.7. And then we have, you could say, moderate positive correlation. Alright, and then if we predict the number of hits on day 1, 21 is our x, y, so let's plug this. We're going to plug equation for the line of best, the regression equation, 2.41x, 22, go to stat, go to y equals, and then go to the table, and then we're trying to find how many hits are going to happen on day 21. Scroll 21, and 51.83. Now use this equation to predict when he will have 100 hits. So this number of hits, the y value, find how many days is going to just take to 100 hits. So on day 37. Alright, that's the end of the review.